This math talk extends our understanding of exponents to include the zero exponent. And so it begins with the question, evaluate 3 to the exponent 0. Now, what you need to understand about this is that really the zero exponent is almost a definition. It's something that we have to have in place so that our rules remain consistent. And so we're going to begin by considering 3 to the exponent 2 divided by 3 to the exponent 2. And I want to call upon what you recall from division of powers. Our rule went like this. If we had 3 to the exponent 2 divided by 3 to the exponent 2, our rule for division of powers said, keep the base the same and subtract the exponents. So that's exactly what I do here. That leads to 3 to the exponent 0. So if we want to continue that rule and keep that consistent, we must say that 3 to the exponent 2 divided by 3 to the exponent 2 is 3 to the exponent 0. Now, I want to look at the other side of this, which is, what is 3 to the exponent 2? Well, 3 to the exponent 2 divided by 3 to the exponent 2 would be 9 divided by 9. And so that works out to 1. And so we come to this conclusion, that 3 to the exponent 0 has a value of 1. Now, let's see if this makes sense. What I want to look at is some powers of 3. Consider this. If we looked at 3 to the exponent 4 and evaluated that, we'd recognize that that's 81. 3 to the exponent 3 is 27. 3 to the exponent 2 is 9. 3 to the exponent 1 is 3. 3 to the exponent 0 must be, well, let's think about this for a moment. As I drop my powers from 3 to the exponent 4 to 3 to the exponent 3, I've dropped the exponent by 1. So I've taken 1 off the exponent. Again, as I drop down, I take off 1 from the exponent. I take off 1 from the exponent. Watch what happens here. This is divided by 3. 81 divided by 3 gives me 27. 27 divided by 3 gives me 9. 9 divided by 3 gives me 3. If we want to keep this pattern going, if we drop this down by another 1, take 1 off that exponent, so we have 3 to the exponent 0, we get, when we divide by 3, 1. So again, 3 to the exponent 0 equaling 1 just keeps our exponent laws consistent. So that leads to the all-important rule for zero exponents. It says that a to the exponent 0 will always be 1 on one condition. A itself never takes on a value of 0. So that's really, really crucial, that a itself is not 0. That's the only one we can't do, but any other base a raised to the exponent 0 will give us a value of 1. Let's try it with a few examples. Okay, knowing that a to the exponent 0 equals 1 at all times, provided a itself is not equal to 0, these questions become really easy to do. 7 to the exponent 0, 1. Negative 15 to the exponent 0, 1. Okay. xy to the exponent 0. Well, applying our power of a product rule, it works like this. X receives that exponent, y receives that exponent. That becomes 1 times 1, which is equal to 1. What about the power of a quotient rule? This would become a to the exponent 0 over b to the exponent 0, which would give us 1 over 1, which would give us 1. Moving on to 3k to the exponent 0. Well, anything to the 0 is 1, so that becomes 1. What about this? 2 plus 3 plus 4, all raised to the exponent 0. Well, anything to the exponent 0 is 1. Okay, well, what happens here? 3k to the exponent 0? We need to be careful here. Remember, we've discussed this before. The exponent acts on the thing to the left and no further to the left. So this is really 3 times k to the exponent 0, which is 3 times, well, k to the exponent 0 is a 1. This answer is 3. So we have to pay close attention to those kind of questions. Next, we have 2 to the exponent 0 plus 3 to the exponent 0 plus 4 to the exponent 0. Well, 2 to the exponent 0 is 1, plus 3 to the exponent 0 is 1, plus 4 to the exponent 0 is 1. And so that equals 1 plus 1 plus 1, which is 3. What's critical is that we followed BEDMAS performing the exponent operations ahead of the additions. I'm going to come back and add one more just side example on this one. Negative 15 to the exponent 0. If that had been written negative 15 to the exponent 0, once again, that exponent acts only on the 15, not on the negative sign. So as a result, we get negative 1. That covers just about everything we need to discuss about zero exponents, and I'm out of time.